Welcome back to our new series on troubleshooting. In the last clip, we showed why taxonomy can be essential for problem solving. In this clip, we will cover some of the most common winding defects, such as cork rush, rough roll edges, starring, and telescoping. Then, we will move on to almost every flatness and wrinkling issue you will ever run into. Let us begin at the bottom of a wound roll to talk about a common and illustrative winding defect, which is not really a defect, but rather a collection of three totally different defects that unfortunately go by the same name, even though they have totally different root causes. Type 1 is caused by winding stresses, and the core gives way during or very shortly after winding. With type 1, you want to wind looser. Type 3, for example, is totally different. The core gives way due to handling stresses and occurs during handling, not winding. Type 3 is totally different because you don't want to wind looser. You want to wind as tight as possible to use the layers of the roll as arches to protect the core. There's also a type 2 core crush that is much rarer. All of these three totally different core crushes require totally different winding strategies as one set of options. However, what they do share in common, besides the trivial one of the core giving way, is that we can change the design of the core in many ways to reduce or eliminate any of the core crush types after the winder card has been played as best as it can. We do not have anywhere near the time to detail the reasons why for this or any of the defects in this clip. That is best left to books, or, much easier yet, my award-winning Web201 class that has been taken by about 5,000 students. All we can do here in this short time is to do the taxonomy and say a little bit on how to diagnose which type you have. Here is a roll with layers that do not line up on a small scale. We will cover large-scale movements shortly in our section on telescoping. It is our job to find out why any layer might not line up with its neighbors. We start by using careful inspection of both edges of a single wrap. The motivation for this care, aside for getting the answers wrong, is that a rough roll edge looks like poor workmanship, even if the roll is perfectly acceptable otherwise. Rough roll edges, not dishing or telescoping because those are totally different defects, is one of the most difficult of defects to troubleshoot. Think of the layers of the roll edges tree rings. Some are narrower than others, indicating a poor growing season. Yet, a narrow ring does not tell you whether the season was too hot, too cold, too wet, too dry, had bugs, or had disease. Similarly, many things look superficially similar on a roll edge. You must be super careful and methodical when troubleshooting. You also need to construct a diagnostic test at each node to see which branch you are on. The good news is that this is not all that difficult if you are creative and careful and spend a moment to get on the right branch. We will let you look through this tree on your own time. If you want more detail, my Web101 class does just that and much more. Also, looking at the end of a roll, you may see starring from time to time. This is an extremely common defect seen on almost all materials. Unfortunately, starring is not a defect. Instead, it is a collection of totally different defects that merely share the same outcome: machine direction buckling of the layers favoring the bottom of the roll. How the layers got buckled is the job of the troubleshooter. Again, we break the major case, starring, up into subcases. For example, if the core crushes or the core is inset from the roll edge, there's insufficient support and the layers collapse, something like a sinkhole. Other subcases are where local web thickness is less, either intentionally, such as coating falling short of the edge, or unintentionally, such as not controlling thickness well. You can read the other subcases and notice that the diagnostics is pretty simple with this winding defect. Note again that you must match the correct subcase with any option list you generate. Thus, for example, improved roll structure by playing with the winder TNTs will not likely help much or at all, for example, if the cause is poor thickness control. Let us move on to one of the more common winding defects, namely telescoping. As you should come to expect, telescoping is not a single defect, but rather a collection of totally unrelated defects that happen to have a similar outcome. The roll edge appears to move outward. Here, we start with type 1A, the garden variety that occurs on core-supported winders, such as pure center winds or center surface winders. In my award-winning and trademark Web 101 school, we cover the diagnostics and mechanics and options in great detail. Here, we will only list the high points. Close observation will note for type 1A that you will have the outer edges line up with the core. You will also commonly observe that the edge is a straight curve pattern. Finally, the key diagnostic is that inner layer slippage down near the core, such as seen by the J-line test, again covered in my Web 101 school. The half dozen remedial options are also listed there. Telescoping case 1B is almost identical in appearance and is identical in mechanics to type 1A. Here, however, it is upon unwinding rather than winding. Thus, for example, you would only have an inner lip and no outer lip. In our Web 101 class, we go through 4 reasons why you might be able to wind a roll that cannot be safely unwound by your customer. Telescoping case 1C is caused when there is a fault in the roll, such as looseness caused by a winder stop. Again, as in the case of type 1A and type 1B, you would have a J-line inner layer slippage, but it would only be at the fault area rather than near the core. Telescoping case 2 is entirely different in almost every respect, even though it looks almost the same. It happens on materials that have lubricant-like properties. The classic example is pressure-sensitive adhesives, or PSAs for short. However, low green tack curable adhesives and even non-wovens can have identical behavior. Again, in our Web 101 class, we go through the distinctions of the diagnostics, such as there's no J-line and the roll edge is bowl or bullet shaped instead of curved straight curve. Solution options are totally different. For example, with type 1A and 1B, you want to wind tight and taper aggressively. But with type 2, you want to wind loose throughout the roll. Telescoping case 3 is a totally different case again, because the loading is different and because the solution list is different. In this case, for example, you want to wind as tight as possible near the core. But as with type 2, taper has no utility. However, with type 1 and 1B, taper is the go-to winder knob. Here is yet another defect that looks like a telescope, but is called dishing instead. Though roll edges superficially look like type 2, diagnostics and solution options are again totally different. And this is not the end of telescopes. There are about a half dozen quite rare ones that I've not listed here, such as clock springing. I don't want to make this more complicated than it might seem. It is actually super easy to know which telescope you have once the diagnostics and the mechanics are explained. The good news is that you will never see most of them in your plant. So all you have to do is become expert in the one or two you and your customer has. Here is what many of you have been waiting for, because it may well be in the top 3 causes of waste or delay or customer complaint for your plant. That is a lack of adequate flatness, whether you call it creases, curl, wrinkling, or whatever. Again, we have nowhere near the time to fully detail this here, because this is well covered in my Web 101 course, as well as an entire chapter in the must-have book, The Ultimate Roll and Web Troubleshooting Guide by Tappy Press. Still, to get started is simple. We even have a free internet app for this. This tree covers perhaps 99% of any web flatness issue you will ever see. They, as always, are grouped into major classes that involve similar appearance, but more importantly, a common mechanics, such as I've listed off on the right-hand side. Subcases, or root causes in layman's language, are usually trivial to determine, as well as the solution options, once you know where on the tree you are. Thank you so very much for letting me introduce and apply the concept of taxonomy to troubleshooting some of the more common web and winding defects. I hope I've made the case that diagnostics is usually simple, and that leads you to the correct list of remedial options. I hope I've made the case that a wrinkle is not a wrinkle is not a wrinkle. Same with core crush, rough roll edges, starring, telescoping, and others. Thank you. Stay tuned for more troubleshooting clips. Please like and share. See you next time.